Hello everyone, and welcome to my session on personalized and inclusive e-assessment. My name is Mario Orsi, and I work at the University of the West of England in Bristol. What is e-assessment? Well, we very generally can define e-assessment as any formative, summative activity that relies on information technology. There are quite a few recognized advantages of e-assessment over traditional pen and paper approaches, especially in terms of authenticity, flexibility, and automation. Furthermore, e-assessment, we have to recognize, is becoming increasingly prevalent also because of the COVID-19 pandemic, the changes brought about, some of which are definitely likely to stay. Let me tell you a bit about the e-assessment system that I've been using. It's called Numbers. So this is an online platform for assessments and learning activities that has a series of pretty advantageous and sometimes unique features. First of all, this is a free and open source system developed at Newcastle University. Numbers is widely used. There are over 1,000 institutions worldwide that use it. It is widely used arguably because it is fairly easy to use. There is no need for any specific digital expertise. If you can use your virtual learning environment, it's not much more involved to learn how to use Numbers. Numbers is great for maths and statistics, but it's very versatile. It can be used for any subject. The key feature, arguably, is randomization. This makes the system smart in that it can easily create personalized assessments, where each student can get a slightly different, unique version of, for example, an exam script. Marking and feedback also can be automated, which can be an extremely useful feature, both for teachers, but of course also for the students. Numbers is highly portable, again, very important. It works on any browser, any device. There is nothing to download or update. It's all embedded and it all works within a browser. Questions and exams, furthermore, are just web pages. Importantly, Numbers conforms to the latest accessibility standards. It is a collaborative tool, so it is very easy to set up shared projects with team members. This is something that I personally take advantage of quite regularly. For example, to develop questions and exams with members of my team on some of the modules I'm teaching on. Numbers also has a very large users community. There is a large database, thousands of questions, and that's, again, extremely useful because instead of reinventing the wheel, it is possible to search for questions that users made available and adapt them to your own needs. Of course, users don't have to make their questions public. This is all easy to control through modifying the appropriate settings. This is an example of a Numbers question. So as you can see, it's easy to add any graphic. And in particular, this question has a series of numerical values. Whenever the question is reloaded, either by a different student or even by the same student that perhaps want to practice a bit more, such numerical values can be made to vary within certain ranges, so that effectively the question changes slightly, the answers will change, and so students need to still demonstrate that they know the process to solve a certain problem. These links are clickable and they will take you to a question, to this question, for you to have a more interactive look. You have to get hold of the slides, or feel free to drop me a line and I'm very happy to share them directly with you. Several question types are available within numbers, for example, true-false statements. I use this type quite a lot, and it's a very general type of question that can be used really for any discipline. It can be combined with randomized numerical values, but not necessarily. In this case, randomization comes useful in that it is possible to create a database of statements, as many as you wish, but then numbers will only display a subset for students. For example, 5 of them. In this case, I can have 100 underlined statements, but when a student accesses the question, 5 will be picked at random for the students to work on. Another type of question is multiple choice, and again, it is possible to randomize the order of choices, numerical values, and so on. Another very nice, smart feature that is especially useful for a math-based subject is adaptive marking, whereby students don't get penalized for errors carried forward, but they may retain the full marks for a certain part, or they can be penalized a little bit. But the important thing is that a mistake, perhaps in the first step of a question, does not inevitably completely remove the possibility for the students to achieve marks later on, even if they can demonstrate learning. Advice and feedback is also personalized, and that's another incredibly useful feature. For example, here we can see some advice from a question whereby the numerical values relate to the randomized numerical values that appear in the question prompt. So students get help in solving exactly the specific question that each of them is assigned. Of course, they need to demonstrate that they know how to solve a question, so when they try again, or if the question is presented to them in a summative scenario, the fact that they received feedback from a previous version doesn't really help unless they know how to solve the question in terms of the procedure. Another very nice feature of the program, which is actually really important, is that names that appear in questions can also be randomized. This is especially good to address the potential problem of stereotyping. Stereotypes in general are bad. They can reinforce unconscious biases. For example, if in certain questions the plumber is always called Gary and the nurse is always called Julie, even if we don't realize, we may well enforce, for example, gender stereotypes. If we use instead uncommon names, then the whole process is much more inclusive, and that is especially true for learners that have an uncommon name. Numbers can randomly pick names using the ONS, the Office for National Statistics, dataset of baby name frequencies in England and Wales in this case, but it's possible to adapt it to any dataset. So every time there is a person's name in a question, the name will change and it will be much more representative of the actual name distribution of a place. Again, there is an example that you can click on if you get hold of the slides. Right, how can we assess the effect of e-assessment? Can we quantify this as a factor that, for example, makes a significant difference in attendance of students? This is the research question that I set out to answer by comparing two different cohorts, one in 2018-2019 that was not exposed to e-assessment. In this case, students were given traditional pen and paper assessment activities. This was compared with a cohort from the following year, 2019-2020, when instead I introduced e-assessment in this module, and we call this the e-assessment cohort. Everything else, as far as possible, was kept the same. So this is the same module. It's a second year compulsory introductory statistics module. The students, of course, are different because these are two different cohorts. However, they are quite comparable in terms of demographic, in terms of distribution of gender, and so on. More generally, staff within the programs remained practically identical. Timetables were also very similar, if not identical. So really we tried to control as many variables as possible so that the only difference was the introduction of e-assessment. The results we obtained were very stark and very encouraging. Here you can see a graph where I'm showing you for each of the 11 sessions what happened in terms of attendance for the e-assessment cohort in orange and the no e-assessment cohort previous year in blue. And I'm plotting on the y-axis the percent attendance for each of these sessions. You can see at a glance how for all sessions, apart from session number 6, but for all the others, in the e-assessment cohorts, the percent attended was higher. And if these numbers are analyzed a bit more quantitatively, then we can work out an average 10% absolute and 20% relative increase in attendance. These results are significant from a statistical point of view. A paired t-test was run and the p-value of 0.007 is small enough to be fairly confident of quite strong evidence for this effect of the assessment in improving attendance. Now we can ask why, or at least we can try to speculate as to why assessment improves engagement. Well, learning activities are more interactive by using a system such as Numbers, where students get to practice more and they know that each of them get a slightly different version of a question. Instant feedback and advice is also important, and it can well prevent disengagement. This is especially the case if students get stuck. If they get stuck, if they don't know what to do, the fact that they can ask for immediate automatic advice clearly it can be a factor in preventing them from disengaging. E-assessment is inclusive, and that's another factor that may well contribute to the improvement we observe. Personalized feedback is automatic and is available anytime. That's very important. For example, for students that may have caring or work responsibilities and may need to practice at unusual hours. Or also for students that, for whatever reasons, may not feel always confident in asking directly lecturers for feedback. The fact that they receive it automatically can, of course, be a great help. The random name feature also contributes to the inclusivity of this tool, and I talked about it earlier. Authenticity, this is again quite a big factor, because students demonstrate their learning in a real-world setting. They use a computer, they use any relevant software, they can access the internet, and they solve unique problems thanks to the randomization. The student feedback that was obtained through anonymous module evaluation has also been overwhelmingly positive. Students in particular highlighted how they really appreciated practicing a randomized question. They valued having an instant result. They thought that, of course, the assessment was overall made clearer and more fair, less ambiguity. And they mentioned how this approach contributed to make them put in extra work and enable them to fully understand the subject. Furthermore, and importantly, they felt like their exam anxiety also reduced, and they felt overall more reassured. Key conclusions from this study: e-assessment has a number of key benefits. In particular, it is inclusive, it is authentic, it makes it harder to cheat. This is especially important when it comes to online remote examinations. Through randomization, we can personalize assessments, and that will remove incentives for students to try and cheat. E-assessment, furthermore and importantly, is loved by students. There are some drawbacks in that, from a teacher's perspective, it can take time to learn. Well, it will take time to learn a new tool such as numbers. However, arguably, any time invested in learning a new platform is definitely recovered later on when, instead of marking, the automated marking tool kicks in. And also, of course, e-assessment may not suit all kinds of assessment activities. A clear case is essays. Thank you everyone for your attention, and feel free to get in touch at the email you see on the slide in case of any questions, if you want a copy of the slide or anything else.